Okay, this is about the seventh time I've tried to make this video, and I'm being mean to people around me and everything else because I just can't seem to get things right. I have been running into battery analysis. There's some person who used to make and take a lot of your money from PayPal charges named Elon Musk, who says batteries are the next big thing, and a whole bunch of other people have told me that's the next big thing. And if you don't pay attention to batteries, you're an idiot, and it's going to be bigger than solar and everything else. And it might be. It totally might be. I'm not skeptical or anything else. I'm not making opinions, but I think this analysis of batteries gives us a chance to really review a whole lot of other issues associated with electricity in general. So I'm going to make a series of videos, and these videos are going to cover a number of things ranging from very practical. I've gone crazy lately. I really have. I'm crazy with the reading the PDF to Excel files. So here's some of the places. Now I'm going to show you where these things are on the Google Drive, and then I'm going to put them in a place on the website. I'll show you them in just a minute. Now, I made a folder named batteries. In chapter 5, if you go to renewable energy, I called it renewable energy, and I put it in batteries. And the place I start, there are two kind of nice things to use. Okay, one is this thing. I put it in the battery section. The Chadbourne, my friend gives me this stuff, and it's all free on the internet. They write up pretty interesting things sometimes, I think. And there's a whole little discussion of emerging storage business models. Okay, that's number one. Number two, on this in the same folder is the Lazard 2.0. Where is this? Lazard levelized cost of storage 2.0. Now in this analysis, Lazard works through they call it the levelized cost of storage. And they have a lot of data that they've made an effort to compile on what the capital cost of a battery is and what the operating cost of a battery. They try to show you that there are all these different value streams. And then they go and make they call it a snapshot analysis, and they use different ISO, integrated system operators, for different regions. 1, 2, 3, 4, 5 different regions. And for each of these regions, they show you, first of all, what the capital cost of the battery would be. They have revenue sources from various capacity charges and ancillary service charges and energy charges. They have operating cost, and we can use this to work through what's in batteries, what's capacity and what's energy, and how do we evaluate the cost. So I'm going to make a file. I'm just going to copy these. This is all free on the internet, no confidentiality or anything else. I'm copying this from the internet with the read PDF to Excel. We're going to put all these assumptions in and replicate the analysis and figure out what's going on. And then they even have the cost assumptions for the various places. Okay. And then they have some more analysis which goes through if you have different types of uses of batteries ranging from an island grid to a peaker replacement to God knows what. They give you all the costs, and I'm going to put all of these costs in a little database. The costs really aren't very different, but they give you the operating cost, the amount of storage of the battery, and so forth. Okay. And then, so that's the first step. The second step, that's replication of the Lazard study. Then, as with so many issues in electricity, so many issues, the whole, at least theoretical analysis, boils down to capital costs for batteries versus operating cost for things like a diesel power station, where you, instead of buying the analysis, you buy the fuel. And in particularly, I'm going to end up talking about the cost of a battery, a diesel, and a solar all together, and see if batteries help the analysis. Or you can do it without diesel. I don't think you can in my island little example. Now, when you do any of this sort of analysis, particularly diesel versus solar, it's really boils down to an analysis of what the capital cost, the cost of capital, because solar's capital and diesel is fuel. Diesel's got some capital and operation too, of course. Solar's got some operation, but that's the key. Now, in order to do that, I'm going to take you through, and we're going to go through in chapter 1. I put a whole lot of data together on commodity prices and on getting futures data and on retrieving historic data on the fuel price. That is a little tricky, and we want to see how you'd even make a forecast. I'm going to not really use anything other than the futures forecast, and we'll see how that would affect our fixed, our carrying charges, our capital cost versus our fuel cost. All right. Then we're going to talk about where you get real data. One of the really frustrating things I'm coming into as I go around talking about electricity to people and asking them questions, more than talking really, I hope, is that I try to put in chapter 5 on this Google Drive. Again, I'm going through kind of where to find all of this. In chapter 5, I go through a lot of statistics on where to get plants. I try to collect things on diesel plants, on Chinese plants. I collect data from the EIA, the IEA. I make a cost comparison sheet that has tries to put all this stuff together. We're going to do the same thing. I'm going to read it in from the various places. Now, the EIA and the IEA, EIA now has some data on batteries, but that data is reported completely different than Lazard data. Diesel, I want to show you how to get real data on diesel, because you see just crazy numbers on it sometimes. Let's talk about where to get real data rather than this generic data, which is all off. These days in Malaysia, they tell me they can build a combined cycle for 500, and EIA still says it's 1,000. That's a factor of 2 difference. Okay, so we're going to talk about where to get data for diesel and solar. And then we're going to work through the LCOE analysis of diesel and solar, and I did it just a little bit here already. And that is where we'll kind of put diesel and solar separately, but the real question is, I don't know what kind of example I have here, but the real question is the total LCOE, I have a really high cost, I don't know what I was doing, is the really high cost of solar, is the total LCOE cost of solar compared to the variable cost of diesel, because you need diesel still at night probably. And to do that, you can kind of put diesel and solar together and see what the total cost is if you put them together versus if you put them separately. So you start with kind of a basic LCOE layout, and then you can do that. And eventually, we want to add the battery and the solar to that. Okay, I'm just, again, showing you where I'm going to go in the next few videos. Hope I get these stupid things done. Okay, where am I? Now, okay. So, in order to finally get the batteries included in this analysis, what we really have to study is we have to study load shapes. You cannot do this without load shapes. If there's a flat load shape, here, this is supposed to be a load for kind of a island, I guess. If there's a flat load shape, you don't need a battery. If you've got a low usage at some point and can move it to a high usage, or this is the place where solar power would be produced and you can move it to the place where people might use it later at night, well, then batteries might be the answer. Or if you have no usage um, at all, you might, uh, uh, um, if you have no usage at all during the sunshine period, the diesel won't do you any good. The only way to use the solar power is to have a battery. So the shape of the analysis compared to the shape of the solar power is an essential thing. I didn't see it in these studies. I didn't see it in these things I introduced. And we're going to work through how to make that analysis. And I don't think it's all that complicated. You just have to kind of count things, which I'm not really very good at. And then we're going to take that study, that Lazard study that has all of that data in, and put it into a database and use that database to finally put our cost, I call it still an LCOE, levelized cost of energy, but we're going to put batteries, diesels, and solar together and see what kind of load shapes you need in order for the batteries really to make sense. I hope I've, in this little introductory video, just given you enough of a kind of overview of where I'm going. And then, I just, in a couple of videos earlier, I talked about all these spot prices. I'm obsessed with getting electricity prices in various places in the world, and then in a lot of these, one like Australia, UK, and some US regions, in Turkey and Philippines and Nord Pool, we have hour by hour prices. And for each of these, you should be able to look and see, well, if we buy power during the off-peak times and then sell it during the on-peak times, what kind of battery cost would this justify? You're going to buy the low cost, sell the high cost. You can do this for 1 day. You can do this for 1 month. You can do this for 1 year. You can do this for 5 years. In Australia, where they have a lot more power spikes, perhaps it's a lot more profitable than in other regions where they have less power spikes and maybe a capacity payment, which maybe you'll get for the batteries anyway. So we're going to look at different markets and see how this would work. Now, when we do this, I do want to just, here's a nice picture of some solar and some batteries and some diesel, and you put it all together and you compare it with the load. How wonderful. That's what we're going to look at. And I wanted to, somebody in one of my classes kind of explain, well, a battery is just like a water tower, I guess. And in a water tower, you have a storage area. And one of the issues I'm going to discuss, is should the cost be met as a function of the storage here, or here, this little thing here, this where you put the water up or down, that's the capacity. That's when you're plugging your computer in and charging it or discharging it. And there's only a certain amount that can be discharged or charged at any instant. That's capacity, and this is the storage. Sometimes it's better to measure things on a capacity basis and sometimes on a storage basis, and that gets very confusing. And I just put here, I put my little battery example. When I go to buy a computer, I travel now. I can't go someplace. I'm so sad I can't use my laptop on the planes and a lot of the places I go. It's making me cry. What am I gonna do? Read a book? Oh my God. Sorry about that diversion. I'm sure I'll get a dislike for that. The I don't think anybody's listening to me now anyway. But when I buy my computer, I ask, how much is the storage? I'll pay a little more for a computer, not much, but I'll pay a little more if you have more storage on the battery. That's the question you ask for the battery. You don't ask what the capacity, how much, what's the rate of charge or discharge. You ask the storage. That's the big deal with batteries. And that's how we measure things. But when we measure capacity, when we measure that the value of capacity in terms of being able to offset a outage or whatever, or a peak load or a demand response, well, the capacity in electricity is measured per kilowatt. Whether capacity is real is such a confusing thing in the first place. Energy we know is real. Energy turns the lights on and the television on and the dryers that you waste all this energy on. And then, but the capacity is some mythical kind of thing that you get paid for. Some, whether you call it like reserve or a seat belt or something. It's something that's not real like energy. So you get paid for this little capacity, which is the rate of charge or discharge. Okay, so those are going. That's just like a little bit of an introduction to the videos, and now the first file I'm going to kind of show you. Why don't I make a file? So the first file, you can see what I'm going to make. The first file is replication of Lazard, and I forgot, what did they call this? Lazard, they call this snapshots, and we're going to do that just to see how it works. Lazard snapshots. Okay, and then look at me. The next thing we're going to do is we're going to do a carrying charge analysis. I've done so much of this stuff. I'm kind of a little embarrassed that I didn't kind of do a comprehensive, but this is going to be a carrying charge analysis for fuel, diesel, solar, and batteries. And we're going to have to evaluate the lifetime of the batteries, the inflation rate in the fuel, all of those kind of timing considerations really should be incorporated in this carrying charge rate analysis. All right, and then we'll make our LCOE. We'll get our data for our diesel and solar, and make our, I'm pressing F12, LCOE analysis for diesel and solar. And what I want to do with this is, I've done this a few other times, but I want to make sure that you can easily incorporate different assumptions about interest rates, cost of capital, about lifetimes, about capital costs. And you're not just reading a study, you can really kind of do it and see the trends. And I'm going to show you again this PV Insights, where you can go and collect data. Well, now that I've started, I might as well finish. I'll show you where you get all this data. So there's a file here called PV Insights, where you can just go, and I've modified that file a little so you can track the cost of solar panels. Okay. And then we'll get some load shape analysis in for the load shape analysis. I hope you're not too frustrated with me, but I've got some real consumer by consumer load shapes. We'll look at system load shapes, and we'll see how much variation there is in the load shapes, and we'll compare those variations in the load shapes to what we really want to see is how the load patterns really work for solar power. So we'll look at some solar power resource assessment and get some of these data sets where you can really see the hour by hour patterns of solar, excuse me. All right, we can think about whether this stuff would work better if you're near the equator. Of course, I think it would, but uh, issues like that. And then we're going to take the battery costs, discuss whether those battery costs are on the basis of capacity or storage. It's a big difference. Some people report battery costs on the basis of discharge and charging and discharging capacity, and that's this EIA. We'll show you what the EIA thinks battery costs are going to be, because they included that in the latest reports. Those EIA numbers are very flimsy, I think. And then we'll be able to do an LCOE analysis with different load shapes. So we're gonna, the next file, I'm gonna go ahead and open the next file, Control N, I already told you, F12, and this is gonna be, I'll put LCOE, even though it might not really be LCOE, but LCOE, how about cost and benefit analysis of batteries with different load shapes. Okay, and finally, we will take some hour by hour data, merchant data. Again, we'll look at places where you have spikes in energy, where you have less spikes, where you have capacity payments. And we'll look at, and why don't we open just one of those files, I suppose. Oh, God. Okay, I just opened our UK database, and we can look at different prices in different hours. In this case, perhaps we should have bought some electricity down here and anticipated these spikes, and maybe just bought the low price and sold it at the high price. I don't know what happened in that one, but you see in UK you seem to have some whoops, I didn't have it for 2011. We have to find out places where we had some hourly data. Okay, and here we could take our battery, buy it and sell it during the peak times. We could try that in different markets and see how much value we get from being able to store the electricity and flatten out the, well, we get a flat price. How much is that really worth? How much is the storage really worth? And how does that compare to the cost of the batteries? And the final thing is, what happens if the cost of the batteries goes crashing down, like the cost of solar power came crashing down? How will that modify the analysis, and will prices just kind of be flat in the future, I suppose? Okay, so that's the overview, and now I'm going to start to do this analysis, and I'm going to put all of this analysis here for you in this file. So I just created those blank files, and those blank files are going to go into this solar page, and I kind of put the little discussion of the solar page here. So this is the first video, and we're going to, hopefully I'm going to be able to, before I leave, I'm going to try to make some more videos on this. Okay, goodbye.